Yeah, it's visible. Yeah.
Okay, so we'll begin. Right. So previous class, we have seen EC2, EFS, storage, all that stuff, right? How to run
Correct.
to the machines, all that.
Yes.
So we'll try
Yes.
to
Yes.
complete EC2 today and start with the databases. We have a few more topics in EC2, right? The
Sure. Sure.
first one that we are going to see is something called EC2 user data.
Okay.
So what is this EC2 user data? Just give me a minute. So what is this EC2 user data? So while creating an EC2 instance, right, what do? First we choose
Yeah.
the AMI, right? We choose the instance type. Then we come to the configuration. We have seen almost all these options, right? So if you scroll to
Yes.
the bottom, you have something called user data and metadata, right? So what is this user
Yeah.
data? That you have to have an idea. So it is basically like a startup script, right? Which you don't need to provide
Okay.
inside the instance, but you can pass the script from the AWS side. So it can be a bash
Okay.
script, PowerShell script, any of those, right? So it is,
Okay.
you can do some configuration like to mount some storage. Say you're creating an instance, right? You want to mount some storage, right? Or install some packages, right? Or start some services, right? It's basically startup script. You can put whatever you want, right? You can put a bash script or a PowerShell script, right? Or a batch file, something like that.
Okay.
It's all your standards. It's not anything special, right? So you can do some startup tasks. So this script, right? It will be executed only the first time the instance is launched.
Okay.
It is not like every time you reboot or you stop and start the instance, it will execute. No. Only when you launch the instance, the first time it will be executed. Afterwards, you can stop your machine, start your machine, reboot your machine. It does not matter. The script will not be executed. Okay? It is only the first time your
Okay.
machine is launched. So you can specify it as, you can copy paste the script over here, or if you have it saved as a file, you can specify that file, right? It has to be encoded
Okay.
in base64 format, but again, you don't have to do it. It will do it automatically, right? You can paste the script over here. For example,
Okay.
let me put a small script, right, which is going to, right? So what this is, a bash script, right? Is going to update the packages, right? Then it will install Apache. It will copy my, so in S3 I have some, say I have my application, right? Which is some application, let us say some website. I have stored the content in S3. Okay. So let me just see. Right. So here I have my website stored over here. That is my content. So what I'm saying is, you download this. So I'm using the AWS CLI command. Okay, we will see this when we come to CLI, how this is going to work. Okay, so I'm saying you copy all the content from this S3 bucket into my Apache default folder, right? Into my Apache default folder, and then I'm saying start Apache, and then make sure Apache is started at every reboot, right?
Okay.
And in order to achieve this, I need to give the permission, because we are not going to log in and do anything,
Okay.
right? We are not going to log in and install. It is going to happen automatic. So in order to access S3, you need to give the permissions, right? Simply you cannot access S3, right? So in order for this
Yeah.
EC2 instance, right? So what is this script going to do? Our script is going to update packages, right? Right. Then it is going to install Apache, and then it is going to
Okay.
copy the content from S3 into the Apache folder, and then it is going to start the service.
Okay.
So
Yeah, and since it yeah, and since you told this script will this script will execute only the first time of the instant restart, right?
Yeah,
Instant start.
yeah,
So it means that first time means, say for example, if I'm creating a new instance today, so it means in that sense, or how it is?
yeah. When you are creating the instance, right?
Yeah. So afterwards it's not at all used, right? This user data.
No, it is not used. Usually, it is not used, right? There are some
Okay.
advanced things
Okay.
that you can make it execute again and all that, right? But we are not going to go into that because not many people they actually use this also. Because nowadays people have
Okay.
other tools to do these things like Ansible, Chef Puppet. They do the instance configuration using those tools. This is rarely used, but you
Correct.
know
Correct.
what
Correct.
it is, right? So it is a quick way to for you to pass some start up some small maintenance task or to start up some service to install packages, those type of
Okay.
things, to mount storage, right? But again, a lot of people they will have the script inside the OS itself, like a scheduled task or a cron job or whatever, right? So
Okay.
instead of doing it inside there, it is also another option which is available,
Mm-hmm.
right?
Okay. Yeah.
It is also another option that is available. So in order to do these things, you need the appropriate permissions because if it has to update the packages and install Apache, it needs to go out to the internet, right? So you have to
Yeah.
make sure you open the security group port because if you don't open the security group port outbound, then what happens? The script will fail. The script is
Yeah.
correct, but you are not given the permissions. So these are some of the possible things where your whatever you have specified might not happen. Why it is not happening? Maybe because you have not opened the security group port, or if you are saying copy files from S3 to this folder, then you have to give the
Yeah.
permissions so that your instance
Yeah.
can access S3 because here we are manually not logging in and doing it.
Correct. Correct.
So here we give something called a role, right?
Okay.
We will see what is a role when we come to IAM. So again, role I think we have seen in S3, what do you say, cross-region replication, VPC flow logs. So what is it basically? A role is so that one AWS service is accessing another AWS service, right? So like you're doing cross-region replication where the data is copied from one bucket to another bucket, or you're using VPC flow logs where the logs from what do you say from the VPC are being pushed to CloudWatch, right? So here basically
Yeah.
this is what is a role. So in this role, what we are doing, we are allowing your EC2 instance to access S3, right? Because we are not going to manually log in the credentials, right?
Correct.
So I have
Correct.
created a role which gives the EC2 instance full permission on S3, so that from this instance S3 will be accessible without explicitly specifying the credential, which is what I have specified here. IAM role for this instance. Right? I have created this role
Okay.
and it has full permissions to S3 and it is assigned to this instance. And this script will run with the root privileges. Right? So this script executes with the root privileges. So there no problem. The problem will come with this internet access or permissions to access other resources. Those type of things you might get a problem and the script might not execute.
Okay.
Okay. So you specify all these things, right? So whatever you want to do, you can specify over. You can create a folder. You can what do you say? Add a EFS mount point. All that. Say whatever. These are all standard commands. This is not any uh, coding or anything. These are just the Linux commands in a what do you say,
Mm-mm.
as a bash script. That's all. Same thing for Windows also. If
That.
you're familiar with PowerShell or you already have some scripts, you can just copy paste them or you can just choose the file,
Mm-mm.
right? The next step is
Right.
the usual stuff. You add the storage, you configure the security group, make sure you're using a security group which has the appropriate access, right? So I'm opening
Yeah.
inbound also because I want to access my Apache on this machine.
Okay.
So inbound is not required because I'm installing Apache. To show you the page, I'm opening the inbound port. But outbound, you need to give internet access. Otherwise, these packages will not be installed because it needs to go out to download them. Okay, so review
Correct.
and uh, launch. And you specify the key and you launch. So the next thing is how do you know whether this script it executed successfully or no, or was there any problem? How will you know that? right? So we have specified the script, it may pass or it may complete successfully, or some place it might have got stuck, right? Like I said, suppose you had not given the permission or security groups, then what will happen? It would have failed, obviously, because it's not running in interactive mode. It is just it runs. So how do you know whether it successfully passed or not? So
So,
you have a
we
log file,
logs.
right, where you can go and see what happened, right?
Yeah.
You can use this also. You
Yes.
can go to instance setting and say get system log, but this is not the correct way, right? Here also it might show you, but there is a log file. There will be a log file inside the instance which you can check. Okay.
Okay.
So now I think probably this instance should be up by now. So let us just open this and see whether our script executed successfully. If it executed successfully, I should be able to see my website. Right? You see, it installed Apache
Yes.
successfully and it posted my website. It copied it from this S3 bucket, all my
Okay.
pages, right? And it
Okay.
started the service. So now even if I reboot this instance, my Apache will start every time, because in the script I have specified that what do you say, uh, to start the service every time, right? I have specified check
Okay.
config HTTPD on. So every time I reboot my machine or stop and start my machine, the HTTP service will start automatically.
Yeah, but here you said you told right. Only the first time instant start like that.
Yeah, so I have already specified this, right? While configuring it, I have said HTTPD service has to start every time. So it is saved in Apache
Okay.
configuration, right? It is saved in the OS.
Okay. So okay. Okay. So it will be whenever you start the instance, it will start.
Yeah, it is not because of this. It is because of this last command. So
Correct. Correct. Yeah.
in Windows, what you do, you go to services and sorry, right? Suppose you want some service to start automatically, you will set it to automatic. So what happens every time you reboot
Correct.
your machine, this service will start. These other
Okay.
services
Okay.
will not start. So because by default Apache will not start automatic. If I don't specify the last configuration, then every time I reboot my machine, I have to go and start the service. Okay.
Okay.
So to avoid doing that, I specified that in the script itself. So it is saved in the, what do you say, like how I showed in Windows, right? So that service is set to start automatically every time. That is not because of
Okay.
this script. This script has finished executing. It has finished its work. It has changed the HTTPD status to always start at every reboot or every stop and start. Okay.
Okay. Okay.
So now I
Okay.
can reboot this machine or do anything. So let us just quickly log into this machine. Right. So let us go into, right. So here if you see, it has copied all my content from the website. Okay.
Okay.
It has started the HTTPD service. So now how do you know whether this script executed successfully or if there's a problem? Now we know it has executed successfully because we are able to see what we did. But in case you are not able to see it, then you can check the log file located at var log, right? So let me go into this, right? So here you have this log file, right? Cloud init output.log. So this log file will show you what has happened,
Okay.
right? So this log file will show you what has happened, right? So here you see it is starting the machine, right? Whatever needs to be done, right? The public private key pair, right? So whenever you're launching an instance, right? So when you start a Linux machine, you will see all this stuff, right? What is happening? What are the services that are starting? So basically, it is logging all that stuff, right? So we saw, right, where the keys, all those things will be saved and all that stuff, right? So all that stuff, so it will come down to the script over here, right? Right? We are doing the update over here, right? It is installing those packages, right? All the updates, and then it is installing Apache, right? So here you will see if it failed or something, you will see the error, okay? Whether anything failed, it's not able to access, right? And then you see it is trying to download these files, right? Some files it was not able to download. So here you see what is it saying? Warning, skipping file aws.png because the object is storage class, unable to perform the operation. So here if you go and see, right? Sorry, in S3, right? This particular file is in Glacier, right? So if it is in Glacier, I told you you can't download the file, right? You have to request it to be to restore first, right? You have to first restore, then only you can download, right? Directly you can't. So you can see that why, suppose you are not able to see this file in your website or whatever, right? So here you can see why it didn't happen, right? So here it says skipping this file because it is in the Glacier storage class, we are not able to download. And then the other files, what happened, whether it is able to download or no, right? And then you see it started the service and it says it finished, right? So by looking at this log file, you will be able to see what happened, whether it succeeded or whether there were any errors or warnings in between. You can see it over here. So you see I had one warning, right? This particular file was not copied, okay? So you can check the logs over here, okay? The path is going to be this, right? Var log, and the log file is cloud init output.log, okay? To see what has happened with your startup, okay? So we call that the EC2 user data, okay? So the next thing is EC2 metadata. Sorry. Next thing is EC2 metadata, right? So these more and more you will use in the DevOps and those type of stuff, right, with scripts and all that stuff. But you should know what this metadata is. So in general, I think in the beginning I have told you, right, what is metadata, right? Metadata is basically data about your data, right? Do you remember? Metadata is
Yes. Yeah.
data about your data. Suppose you have a song, right? Song.mp3. So what is your data? It is this song, right? What is data about this data, right? So what is it? The extension, right? Basically, what is its encoding, right? Who is the artist, right? Artist name, track length. All this is data about this. So all this is basically metadata, right? For anything in general, metadata is some data about your data, right? So now when you talk about EC2 metadata, what is it? It is data about your EC2 instance. So what is that data? Basically all this stuff, right? Instance ID, right? Instance state, instance type, its public IP, its availability zone, its security group. All this is data about your instance, right? Your instance itself, you log in, this is your instance, but all this here is your data about your instance, right? What key pair you are using, what IAM role you are using, right? Whether termination protection, all these things is data about your instance. That's what is basically called EC2 metadata. So the question here is, how do you access the metadata? How do you access the metadata. So you can say I will open the console and I will see over here, fine. But this is for like doing it manually, right? Suppose I give this instance to somebody, right? So if I ask them what is this instance type, how is he going to find out? So I have given this user permission to log into this instance, right? But he does not have any AWS credentials. Say he cannot log into the console. He has only the username password for this machine. He's logging into the machine. So how will he know whether this is a T2 micro or T2 large or M4 large or whatever it is? Right? So he can see the CPU and RAM, but there are a lot of machines with similar configurations. Right? He might not know what type it is. Right? What is the instance ID? Right? What is the AMI which was used? Right? What is the security group which is there for this instance? Right? Why you might need these things? Because in the interview sometimes they will ask you, right? So how will you find information about this instance without using the console? Or how will you find information about this instance from within the instance? Right, from within the instance. So how will you find its AMI ID, instance type, the block device mapping or host name or whatever, instance ID, instance type, right? There are a lot of values, right, about this instance. How do you find it? From within the instance, right? So all this metadata is available from inside the instance at this URL, right? It is 169.254.169.254, right? Do you know what is this IP called? 169.254 IPs, right? So anyway, let's not go into that, right? So in your Windows, for example, right, when you don't have an IP address, right? Some people call this invalid IP address, right? 169.254 or automatic private IP address configuration, APIPA, right? So it is basically like if your machine is not able to get a valid IP address, it will show 169.254 something, right? If your machine is not able to get a valid IP address from the DHCP or whatever, usually it will have 169.254 whatever, right? So here in AWS, for example, this metadata is stored at this path, right? Slash latest slash meta hyphen data. Whether it is Windows or Linux, if you go to this path, you can get that information, right? How do you go to this? You can open it in the browser, you can do it from the command prompt, you can do it from a script, because this is useful not only for manually finding out the information about this instance, but when you're using scripting automation, right, you want to create a machine, and from that machine you want to take its instance ID, because instance ID you will not know in advance, right? If I'm launching an instance, I will not know its instance ID. Only after the instance is created, I will get the instance ID. So say I want to launch some instance, right? And I want to pick up its instance ID and execute some script on it, right? So how do you get the instance ID? In a programmatic way, you need to use the metadata. You need to be able to access the metadata to return those values, right? So how do you access it? You can open this URL, right, using curl or in the browser. I mean, for at the architect level, right? Sorry, right? So here are all the metadata which is available for this instance, right? So if you want to see some particular value, you can go to metadata slash whatever that is, AMI hyphen ID. So when I do this, it will give you this, the AMI from which this instance was launched. You can go and double check over here, right? ABBFF, right? Same thing, right? So what is this instance ID, right? Here you have, right? Where is the here? What is its instance ID, right? What was the key which was used, right? What is the security groups which are assigned to this machine, right? So from within the instance, you will be able to find the values either from a programmatic way or something like this, right? You cannot see the security group rules, but which security group is attached to this machine, or what are the security groups attached to this machine, right? Host name, right? IP address. I mean, of course, IP address you can say IP config or whatever, but you can also pick it up from the metadata, right? Instance lifecycle, instance type, right? Whether hibernation is there or no, right? How are the storage devices mapped? All these things, right? So all these are available under the metadata. What do you say? Category, right? User data is the like the startup script. Metadata is information about this. So you can combine both and you can do something, right? You can combine these things, or you can combine it with other tools which you might use in DevOps to do certain tasks based on certain values. Because we are not going to open the console uh, often, right? To be able to see what it is and manually intervene, right? So we call this EC2 metadata. Whether it is Windows or Linux, it is available at the same path. That is 169.254.169.254 slash latest slash metadata followed by the parameter, right? Okay. Uh, yeah. So now let us talk about the EC2. Sorry, I don't think we have covered this topic, right? EC2 pricing models. Have we talked? Do you remember about talking about this? Because I don't think I haven't made a note of this. So do you guys remember this? Let me just say
No.
on demand, reserved, right? No, right?
No.
Okay. So we'll talk about these things. Right? So let me clear this up. Right. So let us talk about EC2 pricing model. So now we know technical about EC2, right? So how is EC2 built? Right. We know the instance is built hourly. Right. We spoke about this. Right. So Windows is built hourly, and open source Linux, the granularity is in seconds and what do you say? Where is that? Somewhere I think we have spoken about this in the one of the earlier classes, right? How your instances are going to build, what is the minimum building and all that stuff, right? So we know instances are built hourly. Okay? So if you look at your bill, it will say you used say M4 large for some say 100 hours, and you will be billed accordingly, right? So Windows is built hourly, and open source Linux will be in seconds, but your bill will still say 100 in hours. It will say something like 100.1 or 100.01 for open source uh, Linux distributions like Amazon Linux and Ubuntu, right? But still, it is built. So now the question is, how much is it built for, right? How are you built, basically, right? So we know the instances cost some amount per hour, right? Let us say some dollars per hour. So what is this dollar value? How much is this? So you go to EC2 instance pricing, EC2 instance pricing page, right? So let us go to this pricing, right? So here you see they don't have like one fixed pricing, right? They have something called on demand, spot, right? Savings plan and reserved instances and dedicated, right? So it is not like there is a fixed price for EC2 instance. It depends upon what plan you choose, or uh, how can I say? You can say plan or pricing model you choose, right? So what are these basic pricing models or plans? I will just give you the four main categories. One is called on demand, One is called reserved instances, or we simply call it RI. And under this, now they have a category called scheduled. Under this, you have scheduled RI, or scheduled instances, right? People say scheduled instances or scheduled reserved instances, or it means the same. And then you have something called spot or spot instances, right? And then you have the dedicated, right? So in dedicated, again, you have on demand and the reserved, right? So dedicated is, I think I told you in the previous class, what is a dedicated instance, right? A dedicated instance or a dedicated host, right? So basically you have these three categories, and under the dedicated, again, you have on demand or the reserved. But these are like the main categories, right? You can think of this as another category. So let us take some instance type. Let us take, say, m5.large, right? So m5.large is what? It has some configuration, some performance, right? So let us see what is m5.large. Let us go to instance types, right? So here we are talking about M5, and we go to M5 large. So what is M5 large? 2 CPU, 8 GB memory, right? 2 CPU, 8 GB memory, and some network performance, right? So this will be the same, that is same performance, no difference in performance, right? So how much is this going to cost? It depends on whether you are using on-demand, reserved, spot, or dedicated. This is not like fixed price, right? It is not anybody who launches, everybody pays the same price. It depends upon what pricing model is applied, right? What pricing model is applied, right? So these pricing models are mostly for cost optimization. The performance remains the same irrespective of whether it is on demand, reserved, spot, or dedicated. M5 large means here is its performance, you get that performance. It has nothing to do with the instance performance. It is mostly for cost optimization, or this last category is used mostly for what you say, compliance regions, right? Software licensing restrictions, right? Compliance or security reasons, right? Mostly for this, because the dedicated is the most expensive, right? So what is the price, right? So what pricing will be applied? It depends upon what category it falls in. So this is applied by AWS automatically most of the time, right? It is purely for billing or cost optimization, right? So how is it calculated, or what are, how does this work? So let us take a simple example. Say for example, uh, you run a hotel, right? You have a hotel, right? And I don't have a hotel, I'm just a regular guy, right? Okay. So now say you have to buy some stuff for your hotel, right? Say you want to buy the provisions, right? You want to buy rice, wheat, etc. So I need the same things, right? Even I have to eat, so even I need to buy the same things for my house. So the hotel guy, what he'll do, he will buy like 50 kg, right? Rice, like 100 kg wheat or whatever. What I will buy, I will buy like 10 kg, right? 5 kg, right? Sugar, something like 2 kg. I will buy like maybe once a month or something like that, right? This guy, right? You, because you're a hotel owner, maybe you will buy weekly so much, right? So the hotel guy, usually he will go to the shop, or where he'll go? He'll go to the wholesaler, right? So he will get a lower price. Suppose he is buying, suppose say you are buying rice, so you might be paying like say 50 rupees per kg, right? For the same rice, the hotel guy will probably pay 40 rupees per kg. Why? Because the wholesaler will give him some discount because he is buying in bulk. Not only he is buying in bulk, he is going to buy every week. So he is saying, I'm going to buy every week. So he is giving some commitment. He is saying, every week I will come and buy so much. So the wholesaler or the shop guy, he will give some discount, maybe 40 rupees or 45 rupees or whatever. It will be lower than what you pay for, right? It will be usually lower. So why? Because he is giving some long-term commitment, right? He is giving some long-term commitment or quantity commitment or something like that, right? Whereas you, one day you might go to one shop, another day you will go to another shop wherever they have offer or something like that, right? Right? Or if you go to the same shop frequently, right? So that shop guy might give you a small discount, right? Same concept applies here for the instance billing also, right? The same concept applies here for the instance billing also. And what is the other category of how you will be charged? Suppose say a shop is having a sale, heavy discounts. Why they are having heavy discounts? You go to Big Bazaar or certain places, they will have like 50% off, 60% off. Why? Because they are trying to clear the stock, right? If they have excess stock or they want to clear old stock, they will give some more discount even for everybody, right? So those similar concepts apply here also, right? So the first category is on demand. All this is purely for billing, cost optimization. So first is on demand. What is on demand or on demand pricing, right? So it is, you are not giving any commitment. It is the default. So if somebody says an EC2 instance is costing so much, they are generally referring to the on demand price, right? Think of on demand as the MRP. This is what everybody pays. So from exam point of view, if you just go through this page, it is enough, right? Okay, so whatever is given over here, right? So on demand is you pay for the compute capacity by the hour or second depending upon the instances. There is no long term commitments, no upfront payment. You launch an instance, you pay this price, right? So let me open this. So for M5 large, if I launch a Linux machine, right, in this region, I pay, sorry, let us down to, right, so I pay 0.096. So this price is fixed for everybody. Anybody who comes in this region launches M5 large, by default they pay 0.096 per hour. 0.096 per hour. So this is the on-demand price where you don't give any commitment, right? Okay. So everything else is safe. You pay per hour, right? You can start and stop your instance anytime you want. You can start and stop your instance anytime, and you pay per hour for whatever you use, right? Because the other things, it is slightly different, right? So you use for 2 hours, you pay for 2 hours. You use for 3, you pay for 3 hours. You don't use, you don't pay, right? So we call this on demand, right? So after we see the other things, it will be, it will be more clear for you, right? So it is like a fixed price. Even though they say low cost, it is comparatively higher compared to the other things, right? So you don't pay any advance or anything. So think of this as me going to the shop and buying sugar. So if I go to some shop and I ask, give me 1 kg sugar, right? He will give me at that price MRP. whatever is there, 50 rupees. I pay 50 rupees, I buy 1 kg, or if I want half kg, I pay whatever it is, right? Same thing. I'm not giving him any commitment or anything, right? I pay for whatever I buy, right? Tomorrow I'm coming or no, does not matter, right? So this is basically on demand, which is going to be the default. When you launch an instance, if you have provided you have not done anything, right? You have not purchased any other thing, you go launch your instance, it is built at on demand. So if I open my billing, right? So here if I go to my billing, here, right here you see it will say on demand, 4 point so many hours, right? All mine are on demand, right? I pay something. But if I go to some older bill, let us go to something from January 2015. So here if I go, right here you see some of them are on demand, right? For some of them are value is 0, right? For some of them the value is 0. Why is it 0? Right? It will be built, I mean, at a separate price or something like that. Let us go to something in Jan 2016. Yeah, subscription charge. Right? Here you see some of them are on demand, some of them it is not specified as on demand. Right? So what is happening here? Right? So what is happening here? Why some of them are on demand and some of them is not specified as on demand and it is saying 0. Right? It will say 0, but again down it will bill you for it, right? You see 744, 744, 2976, 744. What is 744? It is number of hours in a month total. 30 days into 24, you put, you get so much, right? And for these 4 things, you see a different price has been charged. Why is this happening? What is this? So the next thing is the reserved instances. So it is the same instance. Let us take M5 large, right? The default is on demand. That is, you pay the fixed price per hour. Everybody pays the same price in that region, right? You can do whatever you want in the instance. You can start it anytime, stop it anytime, right? It is totally in your control. Then what is the reserved instances? So here is where you give some commitment, right, for long-term use, right? So say for example you have a project, right? You have some project. So for this it will need infrastructure, right? It will need EC2 instances, right? Right? Say you're having some 3 instances in the front end, 2 instances in the back end, right? Something like this, right? So you will have a architecture for your project. So based on your what do you say, the use case or the application architecture, right? You will have something planned, right? I need 3 instances for Apache, 3 instances for the backend, right? 2 for database or whatever. So you will have some idea, and say this is a long-term project. Suppose you know that it is a project which is going to be there for 18 months. So in real time, the servers in the production, let us talk about the production environment, okay? So they will always be on, right? It's not like you are going to switch off the server, right, in the evening or night. Mostly you will have a steady state usage pattern, a predictable usage pattern, right? So after you deploy this, after a month or two after monitoring, you will know that okay, for this project I need 3 M5 large instances for the front end. I need what do you say, two T2 dot micro for my backend services, right? These will always be on. You might have additional machines which may come now and then and go, but you know that minimum I need these many machines, right? It is not immediately, you may not know. After monitoring for a month or two, you will get a rough idea about the actual usage and how many machines you need at the minimum, right? So you know, so now if you just use it as it is, what happens? You pay the on-demand price. You pay 0.096 for this and something for this, right? You pay the on-demand price by default. Now what you can do to optimize your cost, you want to bring down your cost, AWS has given an option called the reserved instances. So what you can go and do is you can go and purchase the reserved instances. Purchase means like wholesale. So you will go to AWS and you say, I want 3 M5 large instances for 1 year. So what AWS will say, okay, you are asking me 3 machines for 1 year, so you are giving some commitment. So they will say, okay, you take 3 machines for 1 year, instead of 0.096, I will give it to you for 0.06 or something like this per hour. So you are saying not 1 year, I want for 3 years. So then maybe they will give it to you for 0.02 also, right? So they say up to 75% off you can get depending upon the commitment, instance type, OS and all that stuff, right? Up to 75% off on what? On the on-demand price. On-demand is things like MRP, right? If you purchase a reserved instance, you can get up to 75% off depending upon the commitment you give and the OS in the instance type, right? The longer the commitment, the more the discount. Okay, but here what is the condition? Suppose you are saying for 1 year, I want 3 M5 large. So again, here you buy it in the number of instances, but your billing is still in hours. So remember, your billing is always in hours, right? We saw how to convert, right? If you use 2 instances for 2 hours, it is counted as 4 hours. The billing is always in hours, but you purchase the reserved instances in the count. But eventually it is converted to hours. If I buy 3 M5 large, that means it is counting as 3 into 750 hours, because each instance is 750 hours for 1 month. Assuming one instance is running continuously for 1 month, that is 750 hours. So when you are buying 3 M5 large, it means you are buying 3 into 750 hours of M5 large per month. Okay, when you buy 3 M5 large instances, you are actually buying 3 into 750 hours of M5 large. Okay, you can have 4 instances also, but it is the total number of hours that is counted, right? So 3 M5 large is 3 into say 750 hours or whatever, 744 hours for that month, right? 3 into 750 hours for M5 large. That is what it means. Okay, because the billing is always in hours, but you purchase the reserved in the count. Okay, but here what is the condition? So they are giving you some discount because you are giving long-term commitment. But what is the condition is, whether you use it or not, you have to pay for it, right? Whether you use it or not, you have to pay for the hours. You have to pay for this 1 year. Even if you don't use the instance, even if you don't start a machine, or you are using only 2 machines, you have to pay for this entire. That is, you have to pay for 3 into 750 hours every month at this price. Okay, so they are giving a discount because you gave a commitment. So even if you don't use, you have to pay for it. So it is useful for long-term predictable steady state usage. If you don't know what to use, then go use on demand. Right? If you know that for a long term you are going to use, or you have a predictable pattern, you can choose the reserved. In reserved now they have another category called schedule. So normally when we say RI or the, because earlier, right, 3 years ago they had only the reserved instances, 3 4 years ago, right? Which means that when we say RI or just the reserved instances, it is assuming 24 by 7 usage. It is calculated as 24 by 7 usage, which is why I said 3 into 750, right? RI is assumed at 24 by 7. So if you say I want an RI for 1 year, it means you are saying I'm going to use one instance for 24 by 7 or three instances 24 by 7. Then some people started complaining that we don't want to give a commitment like this, because for some people there will be some workloads which run only in which run on a schedule, right? Like development environments or certain servers which come up only during certain times of the day to do certain processes. So they launched something called the scheduled instances or the scheduled RI. So what is the schedule? So you can specify. You can say like every day or every week, I want some instance M5 large, right? I want it for 6 hours a day, right? Or I want it 6 hours per week, right? Or I want it for 200 hours per month. So basically more flexibility in the reservation, because by default RI means 24 by 7, right? Now they have added more flexibility by giving you something called the scheduled instances, or we call it scheduled RI, scheduled reserved instances, where you can reserve your instances based on a schedule. It may or may not be available. You have to check that, right? Scheduled RI gives you more flexibility, but still you give some commitment. If you say you are going to use for 6 hours a day, whether you use or no, you have to pay for that, right? It is just a smaller commitment. You get a lower discount, right? So for some people, scheduled is more, I mean, it gives them more flexibility in cost saving, like development environments or certain servers which might not always be running, right? So they can optimize for cost. The performance is same whether you are launching M5. All this is purely for billing, because while launching your machine, you don't specify on demand or RI. It applies automatically in the bill. If you have an RI, it applies the RI price. If you have on demand, it applies the on demand price, right? If you exceed your RI, it goes to on demand, right? Suppose you buy say 3 into M5 large, right? What is the meaning of that? 3 into 750 hours. So that is some 2300 hours approximately, okay? 2250 or something, right? So basically you have paid for 2300 hours per month for M5 large. Now let us say you are using 2600. Maybe you launched another instance for a few hours, right? So your total bill comes to 2600. So what they will do, 2300 is billed at the RI price. The excess 300 is billed at on demand price. Okay, they are not going to stop your machine or anything, right? You have given a commitment of this. If you can exceed that, if you exceed it, the excess goes on demand. If you don't use 2300 hours and you have used only say 2000 hours, right? You have used only 2000 hours, but you still pay for 2300, right? You can use less or more, but this is the minimum you pay for, because you have already given the commitment. Okay, the commitment can be RI, which is 24 by 7, or scheduled, on a schedule. So how do you purchase this? You go to instances, you go to where is that? Go to the reserved instances, right? And you can say purchase. So here you see in the past I have purchased some reserved instances, 2014, 15, 16. right? So here, if you see, for example, right, I have purchased two M3 large. So let me just arrange this, right? So November 2014, I bought two M3 large. Two means what? Two into 744 or 750 hours. So 1500 hours of M3 large I bought, right? For 1 year, right? The term was 1 year, right? So earlier they had all this heavy utilization, partial upfront, right? Medium utilization. Now we don't have it like that. Okay. Now it is slightly different. Okay. Uh, okay. So again, you see, I bought some 3M3 large at December 2014, because initially when we, when this project or whatever started, right? We started with two, because if I buy too many machines upfront and I don't use it, then it is, what do you say, like a waste of money, right? Because you have to pay for it. So usually when you start, you just monitor it for a week or two or a month or two, so that you know what is the steady state, what is the predictable usage pattern you are able to identify, right? Don't immediately go and buy RI unless you are 100% sure, right? At least not 100%, at least 85, 90% you have to be sure, right? So that you are going to use these machines. So immediately, as soon as they give you the architecture, don't go by RI, because the instance types might change based on real-time use, right? So we started off, right, with something like M1 dot something, then M3 came at around 14 or sometime, right? So we shifted to M3. It is working fine. So we monitored, it was enough. So we bought more of them. So you can buy array anywhere. So you can go to purchase array. You choose the platform, instance type, and all these things, right? What is the payment option? What is the term? So basically, I will just leave everything at default and say search. So let us say I want M5 large, right? Where is M5 large? Not in order. 5 large. Okay. Okay. And I'm saying search. So when you come to the standard array, right? So AWS offers it in 1 year or 3 years terms. You don't have anything in between. Okay. If you see anything in between these values, anything other than 1 year or 3 years, that is 6 months, 8 months, 14 months, like that, right? So it is probably provided by a third party. Right here, you see there is something called third party 12 months, right? So there may or may not be something, right? Here you see third party 2 months. So who are these third party? Somebody who bought excess capacity, they don't need the capacity, because AWS will not refund usually, right? Suppose you bought capacity and you don't need it, you have to pay for it. Or what is the other option is you can put it back on the market so that other people can buy it at slightly lower price maybe, right? So somebody bought some capacity, they don't require it, they have some months left, so they are giving it, right, to recover some money, right? There is no guarantee that third party capacity will be available. This is just somebody who has already reserved the capacity, they are not using it, like buying tickets for first day first show, right? You bought some ticket, you have extra ticket, you can give it off to somebody or to make some money back, right? Same thing, right? Somebody who bought excess capacity or who don't need the capacity, they want to recover some cost, they are putting it back on the what do you say, the marketplace to recover some money. But AWS offers only 1 month or 1 year or 3 years terms for RI, right? So here again you have upfront price, hourly. What is this upfront? Partial upfront, no upfront, no upfront, partial upfront, all upfront. What is this? So again here the concept is same, right? You are going buying wholesale or whatever, suppose you tell the shop guy, I will pay all the money upfront, right? I will give you all the money in advance. Then what he will do? He might give a little more discount, right? He might give a little more discount. Say you are buying some Prime membership on Amazon, right? If you pay every month, you have to pay 129. If you buy yearly, you pay 999. Because you are paying all the money upfront, they are giving some more discount. Same thing here. If you pay all money in advance, which is all upfront, that means you get a little more discount over the, what do you say? You get little more discount basically, right? Or you can pay partial upfront. Partial upfront means what? I'm giving some advance, right? I'm giving some advance. You are buying 100 kg sugar, right, every week. So you are giving off some money in advance. Some money I will pay at the end of the week or end of the month, right? So you will get, say, a little more discount. Or you are not paying any upfront. You are saying I will pay end of the month only. So you get the standard discount. But still you are giving commitment. You are saying for 1 year, I'm going to use 3 M5 large. So this commitment is fixed. So how much discount you get depends upon how you want to pay. Do you want to pay at the end of the month? Then maybe the on demand is, say, 0.06. The reference is going to be on demand. Let us say on demand is 0.06. If you are saying no upfront, maybe you will get 0.04. If you are paying partial upfront, the effective might be 0.038. If you are paying everything in advance, the effective might be 0.032, something like this, a little more discount. The on demand is this. So if you don't pay any upfront, you pay so much per hour, right? Something like this, right? It depends, which is what they are showing over here, right? If you are not paying anything upfront, your hourly rate will be so much, the effective rate will be so much. That is, every month you will be billed so much per hour. Whether you use or no, you will pay so much. If you are paying something partial, that is advance, so they are asking you to pay 252 in advance, right? So you will be charged only 0.029 per hour because you have already paid half the price. So your effective will be 0.058, right? Here it is 0.06, here it is 0.058, a little discount. If you are paying all upfront, that is, your monthly bill will not have anything because you have already paid for it. You have already paid for it. So the effective price that you are paying is only 0.056. Okay, so the effective price you are paying is only 0.056. So don't assume that third party will be cheaper than AWS. Mostly it will be, but it is up to them. They can charge whatever they want. So you want to compare. Usually third party will be cheaper because they are trying to recover their cost. Because if they put higher, nobody will buy it. They will buy it from AWS if it is cheaper, right? You are reserving the capacity. So you are given more preference, right? So what is the advantage of the reserved instances is, it is not only for discount, you are also given more preference. What is more preference? Suppose, so AWS has a lot of capacity, right? They have a lot of capacity for instances. Suppose, say now AWS has only space for 3 M5 large instances, right? Now somebody is coming, right? Say I am coming, I don't have any reservation, right? At the same time you are also coming, you have some reservation for M5 large. So I also want 3 M5 large, you also want 3 M5 large, but in total there are only 3 M5 large available. So it will be given to you. That is, RI is given more preference over on demand. Whenever there is a capacity clash or, right, insufficient capacity or only limited capacity is available, RI is always given more preference. Even though on demand you might pay more, but it is like you reserving a place in a hotel, right? So whoever has the reservation, he is given more preference, right? Same thing here. right? It is not only cost optimization, you also get preference for capacity wherever possible, right? Same thing for scheduled, right? Same thing for scheduled. It is there under scheduled instances, but inside they will say scheduled reserved instances, right? It is the same, right? RI or RI is 24 by 7 usage cases. Scheduled is, or scheduled RI is to reserve your instances based on a schedule, right? RI is called standard RI, standard reserved instances, or just RI we call it, right? So to reserve your instances based on a schedule. If you want 24 by 7, you use the standard RI. That is what I showed you previously, right? So here you can purchase scheduled instance. Again, same thing. You can specify the start date. You can specify the duration, whether it is daily, weekly, or monthly. What is the platform? What is the instance type? You can search, right? If it is available, it is available. It is not available, it is not available, right? There is no schedules matching, right? So you just need to search for it, right? What is the instance type? What is the duration, right? Daily, weekly, or whatever, right? You can search for those things, right? Again, everything might not be available. Available under this type of scheduled, but you can search. You just have to look for what you want, right? In the standard RI, most of the instance types are available, right? You can put multiple instance types and search and all these things. They have some conditions, right? So it provides some amount of flexibility for people who don't want to pay for 24 by 7 workloads, right? So all this, you don't need to worry about the billing. The billing is applied automatically, right? So here, if you see, I have some M4 large, right? So this bill was from January 2016. Now, if I go to the reserved instances, right, where is January 2016? So here you see I have some things which are ending over here, right? So we are talking about, let us go down here to the bill, M4 large. Okay. So if I go to M4 large here, these two, this is also M4 large. Okay. So here if you see for M4 large, I have a total of 2 plus 1, 4 plus 1, right? M5 large, which is still valid at January 2016 because I bought this, right? This was expiring at November 2016, these two, and this is January 2017. So as of January 2016, I have paid for 5 M5 large, right? 4 plus 1, 5. So how much is that? 5 into, let us say, 744. So 3720 hours, right? If my calculation is correct, 3720 hours of M4 large. I think it was Windows. Yeah, it was Windows. And one of it is Windows with SQL Server. So I think we should exclude that, right? One of it was Windows with SQL Server. So we should only put 4. So let me change this, right? 4 into 744. So 2976 approximately. And we have 1 into M4 large with SQL Server. So for this, it is separate price, right? With software, if you buy, you pay extra. So this is 744 hours, right? So totally, now if I go to my bill, here you see M4 large, how much? I have used everything, 2976, right? 2976, 744 hours for January, right? So they don't charge me anything. And here I bought it as what? partial upfront. That is, I paid some money advance. So I will still be charged some amount, right? I will still be charged. So this 2976 you see over here, it is shown as 241. Why 241? Because I was charged how much? 0.081. 0.081 into 24 hours a day into 31 days, right? For one instance. So like this, how many I have? 4 I have, right? Into 4, right? 241 approximately, right? Whatever, right? 241. They charged me the reserved price, not the on demand. But here you see I have another machine, M4 large, right? 498. 498 hours. It could have been one instance or two instance, whatever. It is beyond this. Beyond this, I have used. Right? I was charged at 246. The reserved is 0.081. Right? Excess has been charged at the on-demand price. That is 0.246 into 498. That is 122.51. Here you see it says on-demand. Why on-demand? Because it was excess. Right? So if you don't use all this hours up, you still pay 241. If I use this and I use excess, the excess will be billed on demand. So this applies automatically in the bill. You don't have to do anything. If you have an RI, it applies automatically. If you don't have an RI, it goes into on-demand billing. Right? Same thing for M3 and all these things. You see, I have some. Right? Anything else you don't have an RI, automatically is billed at on-demand price. Okay, so this is purely for billing. AWS calculates it. You don't have to worry about. Okay, the next thing is something called spot instances or spot instances. Right? These days there are a lot of ways to manage these things. Right? But when AWS came out, right, they had spot instances. They still have it. Right? So what is spot instances? It gives the biggest savings. Right? Up to 90% off. How are they giving so much discount? Right? So spot instance is basically excess capacity. So AWS has, we saw right in the beginning of EC2, right? It has a lot of hardware, right? It can hold a lot of instances, right? It can hold hundreds or thousands of instances in that region or availability zone, right? So is AWS using, I mean, is all the capacity occupied? So say each of these hardwares can each have, say, 50 virtual machines. Let us assume, right? It is not like unlimited capacity, right? So each hardware, depending upon its configuration and the instance types which you launch, it will have some limit, right, on the number of virtual machines it can host. So are all these always fully in capacity? No, right? Some servers might be fully loaded, right? Some servers will have some capacity. Some servers are simply there unused, but they need to keep all these things switched on, right? They need to keep it powered on, because only because 4 machines are there, they cannot switch off half the server or something, right? Whether there is 1 machine on it or 4 machines on it, the entire server has to be switched on. It is consuming CPU power, right? So if the hardware is not used, they can't simply keep it off also. A lot of them, because suddenly some customer might come and say, I want to launch instances. So for them, how are they able to quickly, how are customers able to quickly launch instances? Because there is capacity available, right? But all the capacity at the AWS location right? The availability zone is not going to be used fully. There will always be excess capacity, right? So what AWS is doing is this excess capacity it provides at a higher discount to make some money for themselves also, and for you to save some money, right? So this is excess capacity which is provided at a higher discount, but there is no guarantee for this. No guarantee. What is the meaning of this, right? What is the meaning of this, right? So the price is again, price varies. That is, every hour it varies. It is not like on demand, which is always constant, or RI. You purchase something, they give you a fixed discount. You know how much you are paying. Spot is not like that. The price varies every hour, right? The price varies every hour, right? And your instances can be terminated by AWS. So how does this work is, right? So they publish the price every hour. So basically here you have two concepts. One is called the bid price, one is called the spot price, and one is called the bid price. The spot price is the price of that instance. It varies every hour. It can be the same, it can increase or it can decrease, right? Suppose the M5 large, right? What is the baseline? That is on demand price, right? What is the fixed price? Everything is calculated from on demand, the discount and whatever, right? So say on demand is 0.06. So the spot could be 0.01 also for this hour. The next hour also it might be 0.01. Then it might increase to 0.04. Then it might fall to 0.03, right? And it could remain 0.03 for a long time, for a few days also. But every hour the price can change. It may change, may not change, but it is not fixed. It varies hourly, or it might remain same for a few hours and then change. It all depends upon supply and demand, right? The price that is calculated by AWS. They have their own algorithms for the price. And what is the bid price is how much you are willing to pay. So you can say I am willing to pay 0.03. This is the maximum I am willing to pay. So what happens is, as long as the bid price is less than the spot price, your machine is running. If the spot price becomes greater than the bid price, then your machine is terminated by AWS. It is not stopped, it is terminated. Okay? If this price goes greater than what you are willing to pay, your machine is terminated. Or if there is insufficient capacity. Suppose now somebody with on demand or RI, they are coming and saying, we want 3 M5 large. Here some guy is also saying, I want 3 M5 large. But in total there are only 6 M5 large. And out of which 2 you are using. So you will be thrown out. Spot instances have the least preference. So if anybody who is paying on demand or RI, they compete for the same resources, the spot instances are terminated and that capacity is assigned to the on demand or RI guys. Okay, so there is no guarantee that your instance, that you will be provided a spot instance or it will keep running, right? It can terminate mostly based on 2 conditions, that is the spot price goes greater than the bid price, or there is insufficient capacity, that is there is more demand from the on demand and the RI guys, then your machine will be terminated, right? So spot instances these days you can use it in production. Earlier it was not recommended to use in production, but again it depends upon how your application can handle interruptions, your data, right? What type of jobs you want to run, like some background jobs, non-critical jobs, right? So now it has improved, uh, what do you say, a bit, because the person from whom I learned AWS, my ex-boss, right? He started a company called Spotinst, right? He's an Israeli guy, right? So he started this company called Spotinst, and around 3 or 4 months ago, it was sold to NetApp for $500 million or something, right? In hardly 3 to 4 years, right? So this, right? So earlier AWS, it didn't have as much flexibility with Spot, right? So these guys, I mean, they teamed up a couple of guys from my company, right? These two guys, I mean, he was my ex-boss, right? And he was a part of our team DevOps, Israeli guys, okay? So they teamed up, right? So there are a couple of guys from my company also, some of these employees, but these are the two main guys, right? So they've founded, right? The company's name itself was Spot, based on this AWS thing. Now they have other products also, right? But it started off as a way to, what do you say, to predict the hourly prices and to enable you to run production workloads using Spot to save money. And how they used to bill you is whatever you save, you pay a percentage of that. You pay a small percentage, I think 15% of your savings, right? It goes to the billing. There is no other fixed cost, right? They are going to compare the price, right? So they built an algorithm or whatever which is going to predict the usage, right, and replace your instances whenever they used to get terminated, right? But the main condition is your application should be able to handle those interruptions. That is up to your developers and those type of things, right? But I'll just show you a summary of where you can use what type of instances, okay? Because in the exam you will get these type of questions, right? Something like this, right? So when you talk about on demand, it is the least commitment or no commitment, right? Even though they say low cost, it is higher compared to the others, except the dedicated. We come back to dedicated, right? So don't worry about dedicated, right? So you pay per hour, everything you pay per hour, but here they say it is unpredictable workload. So basically, you don't know. You don't want to give a commitment yet. Okay? You don't want to give a commitment yet. They say unpredictable, but for you, you are still evaluating. You're just checking. Okay, I put an environment, right? I'm not sure, or I just want to launch a EC2 instance to do something. You're not going to buy reserved, right? If you just want to say, I want to practice Linux for a few days, you will just launch an instance without reservation, because for reservation, you have to give some commitment and you don't know. One day you might practice, one day you might not practice. We don't know yet. So unpredictable, short term, spiky. In the exam, you get these type of words, right? And you can keep it on as long as you want. You can stop it whenever you want. You can terminate it whenever you want. AWS is not going to terminate your instance. So remember, if you have on demand, your instance is working and somebody with RI comes, you are not thrown out. Okay, you are not thrown out, right? When the problem comes is when there is only one instance, for example, and both on demand and RI are competing for it, then RI will be given this. So if you already have the instance, you will not be thrown out. Okay, whether it is on demand or RI, right? Your instances are not terminated by AWS. Only you have full control over it, right? And what is the result, whether it is scheduled or 24/7? So you have a predictable usage pattern. Based on that, you do the reservation and you pay accordingly. Either it is a 1 year term or a 3 year term, or now you can do scheduled also based on a schedule. So whatever the commitment you give, you pay for that irrespective of whether you use it or not use it, right? And any excess capacity you can resell in the market to make some money. And you also have convertible, right? So say for example, you bought M5XL. You don't need M5XL means you can split it up into two M5 larges. It is available for certain instance types. Convertible, this is called. Right? Again, a little bit more flexibility they are giving. Right? But you still have to pay for it. You can do some conversions like this to maybe use it, but you still have to use it somehow or the other. These are some other flexibilities they are giving. Spot is what it is, the excess capacity, right? But your applications should be able to handle interruptions, and maybe you have some services or processes which can be started anytime, ended anytime, like background processing, reporting, those type of things for which you don't mind your instance being terminated. You can replace them, right? For those type of things, non-critical background. But nowadays it is possible to run production workloads also, but like I said, using a third-party service like Spot or those type of things, right, to intelligently to predict the price and replace your instances proactively, right? So how do you know what is the spot price, right? So while creating an instance, you can choose Spot, right? You can't choose on-demand or RI because it is applied automatically, right? Spot you can do from here, right? It shows you the current price, right? It shows you the current price. Okay, here is what they have given, right? If your maximum price is more than the spot price, your instance is launched, right? If you don't specify a price, then the on-demand price is the default maximum price. Okay, so they are ideal for flexible interruption tolerant applications and lower your cost by up to 90%, right? So you can see the pricing history over here, right? If you go to spot requests, you can do it from here also. Request spot instance, same thing, right? Here you can go to the pricing history, and you can see for that particular instance type, for that region, for that availability zone. Here is the on demand. On demand is always fixed 0.03 for A1 medium. So let us go to say M5 large, right? So here you see on demand is fixed, the line on top. Then you have the purple line for US East 1F. So it is not the same in all availability zones, right? In some availability zones, there might be more supply, more demand, or whatever it is, right? So it is not guaranteed. So in the past 3 hours, you see it has more or less remained the same in all availability zones. Suppose I take US East 1F, right? It has remained constant over the past 3 hours at 0.0529. So if I see for the past 3 months, for example, you will see the price varying, right? So let me remove the other stuff. So we'll keep these two maybe, right? So here you see in US East 1F, the purple line, the price is varying. Sometimes it is more, sometimes it is less, right? And in US East 1D, it has always been lower than 1F in the past 3 months, right? So you can see the history to get a rough idea about how it is behaving, like stock market basically, right? So now, like companies like Spot or AWS itself, they have bought some what do you say, some machine learning prediction, right, to see whether your machine will be terminated and replace it before it gets terminated with in a different availability zone, right? So you can check the prices over here for the past 3 months, right? So to get a rough idea about what has been the trend for a particular instance type, right? Okay, and remember, spot instances, you cannot stop them. They are only terminated, right? Suppose I am going and saying, for example, so let me create, right? Everything about the instance remains the same. Your VPC, EPC, everything. This is purely from billing point of view, right? So now I'm saying I'm launching an instance. Let us set it to micro. I'm saying spot. The current price is so much in the availability zone. So now let us say I'm going to pay 0.036, let us say, for US East 1, or let us choose 1E. slightly higher price, 0.0065 I'm willing to pay, right? The current price is 64, I'm saying I'm willing to pay 65. We'll come back to all these things, right? Right, all this is your usual stuff, right? It is requesting spot instances, right? It will appear just like your instance. Okay, so but these instances can get terminated anytime, so you have to be careful, right? I cannot wait forever, right? Because it depends upon the price and the supply and demand. It might get terminated anytime, but otherwise you can use it just like your instance, right? Your application should be able to handle the interruptions or your background jobs, all those kind of use cases, right? The next thing is the dedicated instances. So what is a dedicated instance? Do you remember?
It's basically owning the physical servers like that, right?
Yeah. So what is the dedicated, right? So I mean, like what you have to remember is in dedicated again you have on demand and reserve. In dedicated you don't have spot. Okay. In dedicated again it has two categories. It can either be on demand or RI. Okay, same concept. So what is a dedicated instance or a dedicated host, right? In dedicated, in the previous class we saw, right? It can either be instance or it can be host. So basically what is happening in your default EC2 configuration, right? We are using the shared tenancy while launching an instance, right? Shared means what? Other customers' instances also come on the same hardware. So what is dedicated? So you are getting, that is your instances will be on a dedicated hardware. Other people's machines will not come on this hardware. That is the dedicated instance. Then what is the dedicated host? Host is like you are assigned a particular hardware. So AWS has a lot of hardware, right? Right, virtualization layer, and your instances are what come on top. So a dedicated instance means AWS will randomly place your machine on some host. You don't have control over that, but no other customers' instances will come on this. That guarantee is there. What is a dedicated host means? A physical host is assigned to you. You can control the placement. So you can buy, say, two dedicated hosts, right? Or for some instance type, you can buy. So when you are launching your instance, you can say, place my instance here, or place my instance here, place my instance here. So you can control the instance placement also, and you get more insight into the, or more control over the, what do you say, CPU cores and those type of things, right? Both are dedicated. That is, other customers' machines will not come on your hardware, right? Dedicated instance. Dedicated instance is AWS. It randomly places your machines on different hosts. Dedicated host means you are assigned a host. So this costs more compared to dedicated instances, and in general, the dedicated itself is the most expensive, right? So again, if you want to optimize for cost, you can purchase RI. You can give some commitment. They will give some discount over the on-demand price, right? That concept is the same, right? In the previous class, we saw about the dedicated host versus dedicated instance, right? Okay. So we'll take a break, right? And then we will continue, right? So yeah, here you see, uh, what is this? Is a spot instance, right? So it is saying you can't stop right? Right. So if you have a persistent request or whatever, it will again start itself, right? But by default spot instance, you cannot stop. Either it is running or it is terminated, or you can reboot it, right? You can read about the persistent request. What is the persistent request, right? So while launching a machine, you get this, right? I want you to read about this and let me know what is that persistent request, right? Here, if you see, it will say put a persistent request, right? Basically, persistent is whenever your machine is terminated, again it will try to launch one more to replace it, right? So by default, your spot, they cannot be stopped and started like your on-demand or RI, right? So either you can terminate it or AWS will terminate it based on the condition, the price or the supply and demand. Okay. Oh, I shouldn't have. Okay, no problem. We've terminated the machine. Yeah. We'll take a small break, right? Okay. 15 minutes. It is 9:52. So 10:02, 10:05 will continue. Okay.
Yeah, sure.
Okay. I'll catch you after the break. Right. So we saw what are the uh, pricing models available. Right. So we'll quickly talk about another feature, right, in snapshots. Right. So now AWS has launched something called fast snapshot restore. Right. So what is this basically fast snapshot restore is, right? So normally what do you say? To restore a snapshot, it takes some time, right? From a snapshot, you say create volume, right? So how long it is going to take? Might take a few minutes, right? If it is a bigger, what do you say, snapshot, it might take more time for you to create your volume. So recently, AWS has launched something called recently means it's been almost a year now, right? Fast snapshot restore, right? So what this basically allows you to do is, right, it lets you uh, create your volumes faster, right? It lets you create your volumes faster. That is, you want a quicker, you want your EBS volumes to be created faster, right? You can enable fast snapshot restore for it, right? It costs additional money, right? But this is just a new feature that you want to, right? So it,
So is that just a clarification? Yeah, yeah.
yeah, word,
Hello.
yeah, word. Can you hear me?
Yeah, yeah, I can hear you.
Yeah.
See, just to want to recap that one, the snapshot which you told last cast, right? So if you want to move the snapshot, we need, sorry, if you want to move the volume, then we need to move the snapshot, copy the snapshot first, then move the snapshot, then we need to create a volume out of it, right?
Yes.
Okay, okay,
Because the volume itself you can't move, right? You have to take a snapshot, move the snapshot,
correct, correct,
from that snapshot create volume. So from snapshot, when you're creating volume, it will take some time. So small volume, no problem. The bigger the volume, the more time it will take, because what is happening is, remember, snapshots are stored in S3, right? Snapshot are stored in
correct,
S3, and whenever you're saying create volume, the data is pulled down from S3 and is returned to your EBS volume. So this will take some time.
correct.
So to speed up this time, you can enable fast snapshot restore. It costs additional money. Basically, that's what this feature is.
Okay.
So if you want, you can read more about it, right? So they are saying it will be restored within some amount of time or whatever, right? So it is
Okay.
available, right, up to what do you say, some limitations and these things they have, right? So here is just what is snapshot, they've described it, right? And fast snapshot restore, right? Can be enabled. All this there is that. Again, this pricing and all this is there for this. Yeah, this one. What's new? This is what you want to read, right? So you quickly want to create a volume, right? So you use fast snapshot restore. There is additional cost if you want to do that, right? And you don't need to do any pre-warming or anything, right? Because from a normal snapshot, if you create a volume, I told you, you need to do the pre-warming if you want to get the full performance. But if you are using a fast snapshot restore enabled snapshots, then you get the performance straight away. You don't have to do that pre-warming step. It is not required because the performance, you get the full performance, right? So basically, this is to, as the name says, to speed up the restore. It is not speeding up the process of taking snapshot. It speeds up the process of restoring the snapshots, right? You pay hourly for it. Okay. So if your snapshot takes say an hour or whatever, so as long as you keep it enabled and you create a you create a volume from that, you can do that. You can enable it for each availability zone because snapshot is there in the region. From that snapshot, you can create a volume in any availability zone that you want, right? So you can just choose that and you say, right? Okay. So now in US East 1A, your snapshot will be restored faster. That is this particular snapshot. It is what you say for each snapshot. It is not for all snapshot. For this particular snapshot, I'm enabling fast snapshot restore for US East. So you can enable this whenever you want and you can disable it after you restore the snapshot. You don't have to keep it enabled, right? So that is one more small feature that was added. This may or may not come in the exam, right? Fast snapshot restore, right? The next thing is, have we spoken about instance store, ephemeral storage? So,
No, it's just no.
so we'll talk about instance store or ephemeral storage. So what is this? So we saw EC2 instance for its primary storage. Where is it coming from? EBS, right? So EBS is what? It is persistent. Right? Persistent means even without the instance, it can exist by itself. That is, the data stored in this is permanent. Right? It is like your hard drive. Even if you terminate your instance, you can keep your EBS volumes. Right? You have full control over the EBS volume. That is the data that you store. So now there is another option for your EC2 instances for storage. Right? For storage, you have another option called instance store or ephemeral storage, both in the same thing. Ephemeral means it is temporary, right? So you will hear these words instance store or ephemeral storage, both mean the same. So what is this instance store? So if you look at this EC2 architecture, right, your storage is coming from EBS, which is what? Which is technically attached over the network, but it appears like a local storage for your OS, but it is actually coming from somewhere else. It is physically attached over the network. This is EBS, it is persistent. So instance store is the storage which is coming from this underlying hardware. Okay, a small amount of storage or whatever, right, amount of storage is assigned to your instance from this physical hardware, right? So this type of storage is called instance store, right? So if I go and say launch instance, right, here if you go, right, here you see two columns. One is instance store. Here it says itself instance store. I don't know why they still call it this, right? They should just say storage and they should put whether EBS or instance store, right? They put instance storage, right? It is misleading, but you see for a lot of instances it says EBS only. So it depends upon the instance type. A lot of instances, these days most of the instances, or almost every instance, uses EBS as its primary. But for some instance types, if you come down, you will see some capacity, right? Like 1 into 75, 1 into 150. What is this? These are like the instance store. This is above and beyond the EBS, right? EBS is there, but you are also getting some amount of storage from the underlying hardware. What is the use of that, right? You will see, right? So it is fixed. You cannot
Uh,
add instance store. Okay, you
so
cannot
that
add.
like
No.
yes, just a thing. So if you terminate this EC2 instance, right? So obviously like EBS volume will be destroyed, right?
No, EBS will not be destroyed. I
Okay.
mean, you can destroy it if you want to, right? For example, if I'm launching
Okay.
an instance, see, EBS is persistent. That's what you have to remember. See, if I'm launching an instance, right? When I'm going to storage, here you have this delete on termination. I told you, right? If this is enabled, your EBS volume is deleted.
Okay. Okay.
If I uncheck this, now if I terminate my instance, my volume will still be there. If I add any other additional volume, by default it is not terminated. It is going to be there. That is, you can control that. It is like your laptop's hard drive. If your laptop is broken, you can still remove the hard drive and keep it aside for the data. If you don't want, you can throw everything away. This is in your control, right? So if you terminate, if you have some storage, say in the D drive, you want that data, you can terminate your machine, but you can still keep this drive. You can attach this drive to another machine and use it, right? So EBS volume, you have control. You can store the data. You can keep the volume independent of your instance, right? Okay, but for some instances, you will also see instance store. Instance store means you will see a value specified over here. So this is beyond the EBS. EBS is there, but you also get something called instance store. So what is this instance store? It is coming from the underlying hardware. A small or a large amount of space. Some amount of space is given. Storage is given to your EC2 instance from this underlying hardware, right? But what is the advantage and the disadvantage? Right? What is the advantage and the disadvantage of instance storage? Any idea?
So I think for ABS it should be locked to one availability zone, but for instance it should be many.
Okay. Okay. So
Or else,
yeah.
yeah,
So
yeah.
instance store, if you see, it is coming from this hardware. So let me draw it again. Right, you have the virtualization layer, you have your VM. For some instance types, you are getting from here. So the name itself, ephemeral, means temporary. Okay. So uh, if your instance has ephemeral storage and you stop your machine, right? If you stop your machine, the data in the ephemeral storage is lost. Okay. Or if this underlying hardware has any problem, then your data will be lost. They might have some, what do you say, hardware trade or whatever, but it is on this single physical host, right? It is not replicated or any such thing. Because what happens when you usually stop your instance and start it again, it starts on a different physical host, right? We saw that in the initial. So what happens? This storage cannot move, right? This storage, it cannot move. So what happens? Your machine will start on a different host, right? And it will again get the same storage, but it will be empty because now that storage is being allocated from here. You will get the same storage, but it will be empty. The data is lost. Your EBS will come as it is. Wherever your instance goes, your EBS will follow it. It is persistent, right? But if you stop and start your machine, what is happening? It is starting on a different physical host, right? Mostly, right? So the instance store will not come. Actually, what happens? It reinitializes the instance store. Even if by chance your machine starts on the same physical host, right? In the rare case, still your instance store will be empty. But if you reboot your machine, it will have the same data, because a reboot usually happens on the same physical host. When you have an instance with the instance store and you reboot it, the data will still be there. But when you stop and start it, the data is deleted, but you will get the same storage space again, but it will be empty. Or if the underlying hardware has any problem, if your instance status check fails, what you are asked to reboot, you are asked to stop and start your machine, so your data will be lost, right? So it is temporary storage. You should not store any critical data on it. You can store, because the performance will be faster than EBS, because it is local. It is coming from here. It doesn't have to go over the network. The performance will be faster. Like you can use it for cache, right? Some temporary logs, like what do you say, swap space, virtual memory, these type of things. You can use it, right? You should not use it to store your database or application or whatever, right? So you can store it. It's not that you cannot store, but the behavior is this, right? In case, because there is more chance of this having a problem than EBS, because EBS, they replicate it for you within the availability zone and all that stuff. So the chance of EBS volumes failing is very, very rare. But your instance store, either the underlying hardware might have a problem, or you might need to stop your machine. In those cases, the data on the ephemeral storage is lost, right? So it is ideal for temporary backups, cache, logs, swap space, those type of things, data which you can afford to lose, or you can afford to recreate, or you have a other copy of your data, for those type of things, right? EBS is for everything else, right? You want data to be persistent. You can use it for everything. Data is going to be there. Even if your machine has a problem, your volume is still there. You can attach your volume to another machine and do it. Here you can't do any such thing. So instance store, it is
And
capacity.
yes, and EBS is for network level, right? Network
No,
storage level, right?
that is EFS,
Okay, EFS.
where you attach it over the network. Here you don't manage the network, right? See,
Okay.
both of them will appear as local storage only. I will create and show you now, right? Both of them will appear as local storage. But where is it actually coming from? EBS is over the network. It is in the background physically attached over the network, right? In the EBS class I showed you, right? EBS volume, it has the
Yeah.
EBS throughput and EBS bandwidth and the network bandwidth, right? EBS optimized, all this we saw.
Correct.
So EBS is physically attached over the network, but you don't manage the networking. EFS is attached over the network. It is based on the NFS protocol, and you mount it as a network file system. EBS appears for your machine as a local storage. Instance store also same thing. It appears like local storage. Both appear as 2 disks. Your OS will see it as 2 disks. But whether it is EBS or ephemeral, you know it by looking at the AWS console. Okay. From the AWS side, it can come either from instance store or EBS volume. Okay. So you can stop and start your instances, right? Your EBS volume data in that will be there as it is. Ephemeral, it is lost. If you reboot, it will be there. If you stop, your data is lost. Okay. So that is what is ephemeral storage, right? Very old, what do you say, instances. Nobody uses those things anymore. But here, if I go to launch instance, right, if I choose an AMI, you will see the first thing called root device type, right? It will say EBS. These days, everything will say EBS. 99.9% people use root device type EBS. What is root device? It is the volume which holds your OS, right? When you're creating an EC2 instance, so for example, let us say Windows, it will be easier for you to understand, right? It says root device type EBS. So what does this mean? That means your, if I go to the next step, right, storage, that means your root device is a EBS volume, right? Which is why you are able to stop and start your instance again. But some very old AMIs, they are still available, right? If you go to the community AMIs and you search with root device type as instance store, right? There are AMIs where the root device itself is instance store. Nobody really uses these anymore, but they are still around, right? What is the meaning of this is, right? So here you see all these are grayed out because all these instance types, they don't have ephemeral storage, right? All the current generation or for the past 3 or 4 years, right? Very old instance types, they support them. So here if you see M3 medium, it is older generation. It has 1 into 4 SSD ephemeral storage, right? It also has EBS. It does not mean it does not have EBS, right? But here now if I go to the next step in storage, here you will see the root volume itself is instance store of 4 GB in size. Here you see IOPS and all these things are not valid because if you create an instance with a root device type as instance store, you cannot stop your instance because instance store is lost when you stop your machine. Your instance is lost. Okay, so nobody uses this anymore, but it is possible. If your root device is instance store, you can't stop your machine. It is lost. Right? So you will see that, but nobody really uses these anymore, but you should know what that is. Right? What is the root device type for your AMI? Right? 99% everybody, we all these days use root device type as EBS. Okay? Whether it is Linux or Windows, it is the same thing. What we use the instance store is for like an additional disk, right? For cache or those type of things that you can afford to use. But it is possible to have your root device itself as that instance store. That is basically your OS is installed on the instance store. Okay, so it can only be rebooted. You can't stop and start your instance. And if anything happens to the underlying host, your server is gone. Right? So here we are using this root device type as EBS, right? But instance type I can choose something which has ephemeral, right? I don't need to say EBS only. So maybe I can say M5AD or something like that, right? So let me see if there is anything small here. All these are right. So maybe M3 medium I can choose, right? It has 1 into 4 SSD, right? So now if I go to storage, right, the root device will be EBS, right? So I can stop, start, reboot my instance. But because it is M3 medium, it has by default one instance store. If you want, you can use it. If you don't want, remove it. There is no compulsion. It is there by default. You cannot increase, decrease. You can't add instance store, right? You can only add EBS. Instance store, it is pre-configured. Depends upon the instance type. If it is there, it is there. That capacity, if it is there, it is there. That's all. You can't modify it. If you don't want, remove it. That's all. You can add additional storage as EBS, right? So here your OS, that is your root volume, is EBS. So you can stop, start, reboot, do everything. But if you stop and start, the data in this is lost. Okay, so we will keep this and we will launch our instance, right? Everything else is same. Okay, RTP will keep review and launch. You just have to wait for it. So again, ephemeral, it is available only for certain instance types. Okay? It is available only for certain instance types, and it is fixed. You cannot increase, decrease, add, remove, add more. If you don't want, don't use it. You can remove it, or you can just leave it as it is attached to the machines, right? So for some people who need good IOPS and throughput, right, for certain applications, they use, right, the capacity and the quantity depends upon the instance. So here you see 2 into 80 GB SSD. So a lot of previous generation machines had it. Then in between, a lot of machines didn't have it. Now again, they are launching what you say, certain instances, right, with again TBS. So if you see M4, M5, they will not have. That is the generation which came in the past 2 3 years. Now again, which has been coming in the past year or so. Now they are again slowly adding this ephemeral storage because certain people need faster uh, local storage, right? Like up to 4 TB, 5 TB also you have NVMe storage and all that stuff, right? See here you see 2 TB and all these things, right? So it depends upon the instance type. So let us go quickly and try to decrypt this password. Right, so which is why usually when you stop your instance, right, you will get a warning. It says that data on ephemeral storage will be lost. Ephemeral storage or instance store both mean the same, right? So they show you this warning because in case your instance is using ephemeral or instance store, the data on it will be lost. So you get that warning. So here is our instance which is created. Now if I open my computer or the disk management, right here you will see two disks. For the OS, it will just appear like any disk, 130 GB disk, one 4 GB. Whether it's EBS or instant store, only you know. Right? In Windows, it just mounts it as temporary storage. Right? In the GUI, you can see. In Linux, it will just be shown as another disk. You can mount it. Right? So if I open my computer, right? So here, right here, you will see it as Z. Right? In Windows, they do this automatically for you, especially in 2012 and all that. Right? So they will just put a file here which says that it is instant store, it is provided at no additional charge, right? It is provides increased performance because it is local to the host, right? The number of disks and it will vary depending upon the instance type. And main thing is the data on this drive will be lost in case of impairment or stopping the instance. Please make sure any important data is backed up. They've given the link. This is just in Windows, you will see this help file. That's all. Right? Suppose say I remove this file, right? I'm creating some folder. Let us say I'm adding some data on this, right? The Z drive, which we know is the ephemeral. Okay, so you can use it just like any local storage. You can create partition format. If you don't like this, you can format it again, right? You can change the drive letter, you can delete again partition however you want. All that is regular, right? But this disk itself is ephemeral, right? So now say for example, if I reboot my machine, you will see the data as it is. So let me go ahead and reboot. Whether you are doing it from inside the OS or outside, it doesn't matter, right? So when you reboot your instance, it will be there. Okay, so we'll just wait for a minute for it to reboot. So let us go back and connect to this machine again. So you will see the same thing. You will see your folder and your data. Now if I stop this instance, right, it will say data on your ephemeral storage will be lost, but data in your EBS volume will be there as it is. So say for example, let us go to the C drive and put something, right? So we have a folder in C and we have a folder in, right? So now let me go and stop this instance. Okay, so let's go and start the instance again. So let us talk about instance store. Right. So here you have the details about it. If you're more interested about instance store, you want to use it especially for database, those type of high speed storage you need, right? So this is what is instance store, right? So it is physically attached to the host and it is used for buffer, cache, all these temporary content, right? These type of things, right? Data which you can afford to lose, basically, right? So this is how it is, right? Your host has some amount of storage which is shared amongst those things. It depends upon the instance type, right? This is the lifetime I told you, right? If there is a problem with the underlying disk or your instance stops or your instance terminated, the data in the instance store is lost in any of these cases, right? it is, don't rely on it for valuable long-term data, right? For that you use, because in the exam you get these type of questions only, right? You have valuable long-term data that needs to be stored, means you use EBS or S3 or EFS, because data you store in that will be there until you delete it, right? It will not be removed automatically or those type of things, right? So whenever you stop or terminate your instance, right, that instance store is reinitialized, or it is reset, so you cannot access it again, right? Because again your instance starts on a different host mostly, right? So it is not preserved, right? So same thing, if you create an AMI, it is not preserved, right? And when you launch, what do you say, instance with EBS, with the root volume as instance store, again it is not going to persist. And if you change the instance type, then the instance store will not come with it. There are different possibilities. Right now I launched it as the same instance type. Again I started it as M3 VM. Suppose I had changed the instance to M4 large. If you see M4 large, it does not have instance store, so your instance store will not come. Your root volume, your server will come as it is, but your instance store will not come along, right? So if you change the instance type also, and obviously to change instance type you need to stop your instance, right? So if the new instance type it does not have instance store, it will not get it, obviously, right? So here are what they are just showing you what are all these things, right? So whether you need to initialize it or no, initialization is the same thing, right? Pre-warming, right? Same thing for this also. For certain instance types you need to do it, for certain things you don't need to do it, right? And then you have this thing, right? Adding instance store, SSD instance store volume, right? These type of things, right? Swap space, all that. This is just basic, right? You can go through this. I mean, if your use case dictates you use instance store, so how to optimize it for performance or how to get the full benefit of it is given over here, depending on the type of instance store uh, you have, right? It might simply be plain SSD, or it might even be NVMe, which are newer types of SSDs, faster SSDs, right? So let us log back into this machine. Right now if you open my computer, because it's Windows, it automatically formats and it mounts the disk, right? If I open C, you see we still have our folder what we created, that is the same server, same stuff as it is. But if you go to Z, you see it has been cleaned up and again initialized, right? So the data in your instance store is lost. When you stop or terminate your machine, you cannot store it. If you want to store it, you back it up to EBS or back it up to S3 or PFS, whatever it is, right? So you cannot add, decrease, modify, all that stuff. Okay. So let me know if you have any questions now on EBS, on instance store. Okay. So I'm going to terminate this instance also. Okay. So here you see on a EBS backed instance. What is EBS backed instance? EBS backed instance means the root volume is EBS, right? Right. So it depends on what you have set, right? Whether the root volume is going to be deleted or not, it depends upon what action you have set while launching the machine, right? So you can control EBS persistence, whether it should be there after the instance is terminated or no. But as long as the instance is there, the volumes attached to it will be there. Right? So the next other small thing that you need to know is EC2 Hibernate. What is this EC2 Hibernate? Right? So do you know what is Hibernate? might have come across hibernation in Windows, right?
In Windows, yes.
So what does it do? It basically, let me clear this up.
You just it's a kind of soft shutdown, something.
Yeah.
You won't shut down the machine, it still stop that resources
So
utilizing
basically,
the power.
what it is doing, it is taking all the content in the RAM and storing in the hard drive, and then it switches off your machine. So the next time you power it on, right, it is going to be faster, right? The services might start up faster, your machine might boot up faster. For some people, they might want to do hibernate instead of doing a full shutdown, right? So now in EC2 also they started supporting it. Earlier it was not there, right? Now your EC2 instances also can be hibernated. So when you hibernate, what happens? Whatever is there in your the current running processes and all that, right? That state is stored in the HDD, right? If you see on Windows, it will have a what do you say, hyperfile.sys or whatever, that hibernation file, right? That is basically it is storing the current state into the hard drive. Here also same thing. The state is stored in your hard drive. What is your hard drive? EBS, right? It can be SSD or whatever your EBS, right? And your machine is hibernated, right? Okay. So with EC2 hibernate, same thing. That is your RAM state is preserved. It is going to switch on much faster. I mean, for some people it might be useful. Suppose they have some process which takes some time to start up or initialize or whatever, right? So they can use hibernate to speed it up instead of switching off the machine and starting it again, right? So for this hibernate, right, there are some conditions, right? So you cannot enable hibernation after you launch the machine. So if you want your machine to be hibernated, to support hibernation, then it has to be enabled while you are launching the instance, right? While you are launching the instance, in the configure details here, you will have the hibernate behavior, right? Enable hibernation, right? If you don't enable this, you can't enable it afterwards, at least at present. In future, they might let you modify it afterwards, but currently, you cannot enable hibernation if you don't enable it during launch time. Okay. Okay. So here you have to make sure that the root volume is large enough to store the RAM contents. And the condition is the root volume has to be encrypted because it is storing your RAM state. For security reasons, it is supposed to be encrypted. That is, your root volume has to be encrypted. Suppose you have a 60 GB RAM server, then you should make sure that your EBS volume also has enough space because it is going to take up space, right? If your RAM is heavily utilized, right, and it has to store the entire contents state, you should have space, right? So those are two important things, right? Make sure you have sufficient capacity in your root volume and that the root volume is encrypted, right? Here you say to enable hibernation, encrypt the root volume, right? So you can specify your default encryption key, or you can upload your own encryption key and encrypt it, right? So without encryption, you cannot hibernate your EBS volume, right? So for services like which take a long time to start up, right? To quickly start up your instance, you can use EC2 hibernate. And again, it is not supported with all instance types currently, right? I think currently only C3, C4, C5, C6 also is not. I think same thing with R3, R3, R4, R5. I don't think R6 is still supported. Same thing, M3, M4, M5. These are probably the instance types and maybe the T family, right? So it is, don't assume that it is there for all instance types, right? It may or may not be there, right? Currently, I don't think it is supported for all instance types, right? So that you will know only when you go through one by one, but just remember it is not supported for all instance types. If you want to know what are the instances which are supported for Hibernate, AWS has the document for it, right? So if you need hibernation, just double check whether your instance type supports hibernation. Don't assume that it will support hibernation. Okay, so maybe we'll see something which does not support hibernation. Right, so here also it is enabled. Probably they are adding more and more, but don't assume that this will be there for everything, right? Okay, so that is one more thing. Another condition is these are some of the important points that you need to remember. There will be other conditions and terms, but first thing is it has to be enabled while your instance is being created. Then the supported instance types, right? And what is it? The RAM has to be less than 150 GB. Currently, this is the limit, right? So if you try to launch an instance which has greater than 150 GB RAM, right? It might not be supported. I mean, it is not supported currently, right? So all these are small instances. Say, for example, I go for something like this. Hibernate may not be supported. I don't think it is still. Right here, you see, you don't have that Hibernate option, right? So your RAM should be less than 150 GB. In future, they might increase it. Currently, this is the limit, right? And again, the AMI also, they support it for Amazon Linux, right? RHEL and all those you have to check, because to enable hibernation, you might need to do it at the OS level also for certain Linux flavors, right? To enable hibernation, right, you might need to enable it at the OS level also for it to support Hibernate feature. It is not enough with just you can do it from the AWS side, from the OS side also you have to. So you have to please check the AMI whether so Amazon Linux instances support, Windows also support, but if you are using something like RHEL or SUSE or something, you want to double check and see how to enable hibernation from inside the OS, right? And you cannot hibernate for greater than 60 days. 60 days is the maximum limit that you can hibernate your instance. What happens after 60 days, even I don't know. I haven't hibernated for so long. According to the AWS documentation, your instance cannot be hibernated for more than 60 days. I think it will start up automatically after 60 days because it happens for RDS. For EC2, I have not yet hibernated for so long, for 2 months. But the limit is it cannot be hibernated for more than 60 days. Okay. So these are some of the things that you need to know. Right. So if you go to EC2 Hibernate, right. So here is what they are saying what will happen. Right. RAM contents are reloaded. The previous running processes are resumed. Right. And all your volumes and all these things remain the same. Right. So here are some prerequisites which we saw. Right. So all these are the supported instance families. T2 and all these things are for R5A less than 150, not supported for bare metal, right? Supported AMIs are these things, right? Anything else you need to double check and configure your AMI to support hibernation, right? Support for other versions, so they will keep adding. So this is what is currently there, right? Just high level you need to know basics, right? So don't assume it is there for everything, right? You might need to enable it at the OS level by enabling these things, right? Here it is showing only the Linux flavors because we are using the user guide for Linux. If you open the user guide for Windows, same things will be specified for Windows with the supported Windows versions, right? So don't say Windows is not supported because it is not showing here. It is not showing here because this is the guide for Linux instances. Same thing, you have the guide for Windows instances, right? Then it has to be encrypted and all these things, right? Just high level and limitations, right? So you can't change the instance type when the instance is hibernated. You have to stop it and hibernate, right? You can't hibernate which is greater than 150. You can't hibernate instant store back AMIs. We just saw what is instant store back instances, right? Where the root device is instant store, so they cannot be hibernated. But anyway, nobody uses them anymore. But still, they've just specified all these things, right? So you can't hibernate for more than 60 days, right? So for more than 60 days, you must hibernate, stop, and again start it, right? So all these things are there. Okay. So if you are more interested in troubleshoot, you can troubleshoot, right? So you must wait for 2 minutes after lunch before hibernating all these things, right? Some of these things we take for granted, but these are some of the issues you might come across, right? So that is another feature, EC2 hibernate. Okay, so with this we have completed in the sense from exam and a little bit of practical point of view, EC2 stuff, right? So probably we have I haven't shown you VPC endpoints, so probably tomorrow we will see that, and then we will, tomorrow is 11th October, right? So tomorrow we will talk about VPC endpoints, and we'll talk about ENI and EFA, right? So VPC endpoints we didn't see while talking about VPC. I told you after EC2 we'll talk about it. So these two we will see in the first half an hour or so, and then we will start with the database service RDS. So are any of you guys from a database background?
Yes,
Either of us.
I came from.
Because I am not from database background. Don't ask too many questions. That's all. Again, so see, if you are from the database background, because you have to know your database administration or development, right? So on AWS, we will see how to, I mean, what are the features you have and how to use it, because I'm not going to teach you Oracle or Microsoft SQL Server. All those remain the same, right? So how you can start using in AWS, what are the features, we are going to learn it. That level. Don't ask me how to migrate database, those type of things, right? Those type of things you have to explore. Those things come in the database specialty exam, that is for core DBS. So in the architecture and ops exams, right, how to, what do you say, what options to choose, how to create high availability, those type of things are covered. Okay, so if you are going to work more on databases, then RDS is probably one of the service you want to pay more attention to. But in order to learn RDS, you should know what is EBS, what is EC2, what is VPC, what is S3, all those things you need to know. Because straight away, if you try to learn RDS, you will not understand it, because it depends on the other stuff also. Okay. So tomorrow we will complete up the little bit. I thought we can finish today, but took a little longer. No problem. So tomorrow we'll complete up the leftovers in EC2 and start with RDS.
Sure.
Alright.
Right. Yes. Thank you.
Thank you.